guys, welcome back to Wong Chemistry channel. This video is the part 3 video of your 7.3 Solubility Equilibria. In this video, we are going to discuss about your quotient. Your quotient will be compared with your solubility product. If you remember, your solubility product is your KSP. So we are going to compare the quotient Q with your solubility product KSP. Alright? So, what is actually quotient Q? If you remember, it works exactly the same like your QC and your QP, where you are going to compare with your KC and your KP. Alright? But your Q today will be then compared with your KSP that you learned in your previous video. Quotient is the ion products which have the same expression as your KSP. So, the way that we write the formula for the quotient Q is the same as the way that you write for your KSP. But the concentration used is not at equilibrium. Okay? So, for example, the equation that I have over here, the KSP for this equation will be the concentration of your Ca2 plus multiplied with the concentration of your F minus ion to the power of 2 due to the coefficient of the fluoride ion there. Okay? So as you all know, K over here is your equilibrium constant. If you remember, your K is always the equilibrium constant. And therefore, the concentration over here must be the concentration at equilibrium that you calculate from the ICE table. Remember that? But how about your Q? Your Q over here will have the same expression. In the other words, your Q will have the same formula as your KSP. Alright? But what makes it different over here is the concentration that you put in is the concentration not at equilibrium. It's a concentration that we don't know whether we have achieved equilibrium or not. Okay? And this is the main difference between your Q and also your KSP. Where again and again your KSP is always the concentration at equilibrium, while your Q, your quotient Q, is the concentration not at equilibrium. Okay? But if you look at the formula or if you look at the way that you write the expression, will be the same. And the expression, both of them must be coming from your balanced and correct chemical equation. Alright? So, why are we comparing the quotient Q with the KSP? Because we want to determine whether we have precipitation occur or not. Alright? We want to check whether your solution right now is saturated, alright, or unsaturated, or your solution is a supersaturated solution. And we can check the type of solution at the same time when we are checking the precipitation. So, that is the reason why we are comparing your Q, your quotient, with the KSP solubility product. We only want to know the type of solution that we are having right now is saturated, unsaturated, or supersaturated. By determining the type of solution, we can also know what happened to the precipitation. Do we have precipitation or we are not having precipitation in the solution? Okay? Just a kind reminder, if you remember, your KSP over there represent the maximum ion that you can form in a saturated solution. Okay? So, what is meant by saturated solution? So, that is our KSP. KSP is the maximum ion that you can have to form a saturated solution. Okay? So, what would happen when the Q is equals to KSP? What does that stand for? What would happen when the Q is less than the KSP? What does that stand for? Okay? And what would happen when the Q is more than KSP? What does that again stand for? Alright? So, before we start comparing them, you need to remember one thing over here. Your KSP represent the maximum ion that you can have in a solution to form a saturated solution. Okay, so remember that KSP actually represents saturated solution. Alright, so what would happen when the Q is equals to KSP? When your KSP over here represents saturated solution, so what would be the type of solution that I have when my Q is equals to KSP? Simple, it's a saturated solution. But the question is, how do we define a saturated solution? A saturated solution over here means when you have a beaker and then you're having your solution, you're adding in your salt, your partially soluble or your insoluble salt into the solution. And how do you judge that is a saturated solution? What do you mean by the maximum ion that you can have in the solution? How do I know that is already my maximum ion? Simple. It's a saturated solution when you keep adding in your salt until one moment that your salt is not going to dissolve. No matter what you do to the solution, no matter how many times you stir to the same solution at the same temperature. Alright? When the temperature doesn't change, the solution doesn't change, and you realize that there is a little precipitate that you form that is not going to dissolve no matter what. That is the moment that we categorize the solution as a saturated solution. And therefore, a saturated solution will always come with a small amount of precipitate. Alright? So always remember, when it's a saturated solution, you will always have the small amount of precipitate in your solution. Alright? And next, what would happen when your Q is less than your KSP? Your Q over here is actually the product to the power of its coefficient, which is actually your ion, your cation to the power of its coefficient, and also your anion to the power of its coefficient. Knowing that both of the cation and anion over here is the product. Agree? And right now, your Q is less than your KSP. When your Q is less than the KSP, that means your product is also less. When the product over here, your cation and anion is less than the KSP, which means this is less than the maximum ion that you can have in the solution. So, when the amount of ion that you can have is less than the maximum, that is the reason why your solution will be categorized as an unsaturated solution. And since it's an unsaturated solution, guys, where you can dissolve more salt, right? You can dissolve more salt. Therefore, there will be no precipitation. Alright? Simple. And last but not least, what would happen when your Q is more than your KSP over here? So, as always, your Q actually represents the concentration of the product, your cation and anion, to the power of its coefficient at the balance equation, right? So, right now, your Q is more than the KSP. When your Q is more than the KSP, that means your ions that you have over here is very high. And knowing that your KSP is the maximum already, and right now your Q is larger than the maximum. Alright, when it's larger than the maximum ion that you can have, that means your solution is a super saturated solution. When it's a super saturated solution, there will be no more salt that can be dissolved. Of course, because your ion that you can have in your Q right now is already more than the maximum ion. When it's already more than what you can have, therefore, no salt can be dissolved anymore. Alright? And that also means you are going to have a large amount of precipitate occur because it's a super saturated solution. So, we only have three conditions. When the Q is equals to KSP, when the Q is less than the KSP, or when the Q is more than the KSP. Alright? And next, the most important thing, how do I solve the question? Right? How do I know my Q is less than the KSP or more than the KSP or equals to the KSP? how do I find my Q? That is the biggest problem. Here are some steps that I hope it will guide you when you are solving your question. The first step is you must identify the insoluble salt. How do I know that it's an insoluble salt? Which one is the insoluble salt? Simple. Look at the KSP given. Look at the KSP is given to which salt. That is the one that we are looking for. Of course, if the question is not giving you the KSP, then the question should be asking for the KSP. So the salt that the question asking or giving based on the KSP, that is our insoluble salt that we are looking for. Alright? And whenever you have the insoluble salt identified, guys, the next thing is definitely chemical equation for the insoluble salt. Make sure your cation and your anion is correct and also balanced. Okay? Please make sure your equation is balanced. Whenever we are writing equation, the equation must be balanced. Alright? The next step is when you already identify the cation and anion that you need in your insoluble salt, you need to then find the number of mole of the ion needed to form the insoluble salt. So bear that in mind, we are only finding the number of mole of the ions that you need for your insoluble salt. And why do we find the number of mole but not the concentration straight away? Because normally the volume will change. Alright? So please remember, when the volume change, the only thing that will remain the same is your number of mole. Next, when you have the number of mole already, find the new concentration. Find the new concentration of who? For the ions that you calculate above. Okay? For all the ions that you calculate above, you are going to change it to the new concentration because the volume total change. So make sure you are using the new volume total. Alright? And the next thing, definitely calculating your Q. Simple, using the same expression as always by using the chemical equation that you write in the second step. Make sure you have a correct and balanced chemical equation before you write your Q. Last but not least, what else if not comparing your Q with the KSP? That is the purpose after all, right? So make sure you get the correct Q before you compare your Q with the KSP. Here are some steps that will guide you on how to solve the problem. It's not necessarily exactly the same step. It will very much depend on the question, alright? But generally, this is the things that you need to have before you calculate the Q, okay? So let's go for the first example over here. In the question stated that 20 milliliter of 0.1 molar barium nitrate are added into 50 milliliter of 0.1 molar sodium carbonate. Did you see the word added into? Okay. So which means the volume right now changes. Can you guys see that? Next, the question is actually asking, will the barium carbonate precipitate? And the KSP is given for barium carbonate. So right now, looking at your question, you have three different salts. Your barium nitrate, your sodium carbonate, and your barium carbonate. So which salt is the one that we are looking at? Which one is our insoluble salt? Remember I said the one that with the KSP given or the one that the question asking for the KSP. So the first step is to identify the insoluble salt. And our insoluble salt in this question is your barium carbonate. Alright? Knowing that your barium carbonate over here, break it out, will be your barium 2 plus and your CO3 2 minus. Agreed? Let's understand the question a bit over here. So right now, I'm having a beaker and into the same beaker, I'm pouring in 20 milliliter of 0.1 molar barium nitrate. Okay? The first thing that I put into my beaker. And then into the same beaker, I'm pouring in 50 milliliter of 0.1 molar of my sodium carbonate. Okay? Knowing that your barium nitrate over here will form your barium 2 plus and your nitrate NO3 minus. sodium carbonate will form your Na plus, okay, carbonate, CO3 2-. So what will happen is, we will have the changes between the cation pairing and the anion pairing. So the barium 2 plus will be then partnered with the CO3 2-, and the nitrate will then be pairing with the sodium. So when they're in the beaker having your barium 2 plus and your NO3 minus and also your sodium plus and CO3 2-, they will exchange the cation and ion, forming your barium carbonate and also your sodium nitrate, okay? And in the two salts that you produce from this solution, we are looking at which one? Obviously, the question mentioned about KSP for barium carbonate. Therefore, we will only focus on the barium carbonate. Can you see that? Alright. So in the other words, your barium carbonate is the one that will be insoluble salt. Make sense? And at the same time, what would be the volume of this solution? The volume of this solution will be 20 milliliter plus 50 milliliter. Therefore, the volume total will be equals to 70 milliliter, which will then equals to 0.07 liter. Alright? And I hope you will remember one thing. When the volume change, your concentration will change, but the number of mole will remain the same. Okay? Therefore, we need to find the number of mole for some ion. Which ion we are looking for? The salt that we are looking for is barium carbonate. Therefore, the ion that we are looking for is definitely Ba2 plus and CO3 2-. So we are looking for barium 2 plus from the barium nitrate, and we are looking at your CO3 2- from the sodium carbonate. Can you see that right now? Okay, so we need to find the number of mole of this and the number of mole of this. Alright? So I hope you understand the question right now before we start doing the calculation. So now you have understand the question and you know what the question is talking about. So how do we proceed and solve the question? How do we calculate the Q? The question is asking for the Q, and how do I know whether that is precipitate or not? Okay? So remember your step 1. Your step 1 is going to identify the insoluble salt. So from the question, we know that the insoluble salt for this question is your barium carbonate, as we mentioned just now. And knowing that in the barium carbonate, we have barium 2 plus and your CO3 2-. Okay? And then you're going to proceed to your balance equation of your barium carbonate. So your balance equation of barium carbonate will be forming 1 mole of barium 2 plus and also 1 mole of carbonate ion. Okay? Next, after you have identified the insoluble salt, you have write the equation. How do you proceed? We are going to calculate the number of mole of ion needed and the new concentration. So there are actually 2 methods of doing it. The first one is the one that I give you just now. The 20 milliliter of 0.1 molar of your barium nitrate. So the first method is using your MV over 1000. Okay, to calculate the number of mole, you can have your MV equals to 1000 where the concentration is 0.1. Volume is 20 over by 1000. So from there, you realize that the number of mole of your barium nitrate calculated will be equals to 2 times 10 to the power of negative 3. That is the number of mole of your barium nitrate. But we need the number of mole of the barium. So 1 mole of your barium nitrate produce 1 mole of your barium 2 plus. Therefore, number of mole of your barium 2 plus will then also equals to 2 times 10 to the power of negative 3 mole. Alright? But we do not stop at the number of mole. We want the concentration. So, to find the concentration, we need the new volume total. And the new volume total over here is your 70 milliliter, which is also equals to 0.07 liter. Alright? Therefore, from that, we can calculate the concentration of your barium 2 plus by using the number of mole and also the new total volume 0.07 liter. Therefore, the concentration of the barium 2 plus calculated is 0.02857 molar. And that is the concentration of our barium 2 plus that we are looking for to calculate the Q. And as I said, there are two methods to calculate the concentration. One method is using the MV over 1000 from the number of mole changed to the concentration. Another method that I can show you over here is if you are having 50 milliliter of 0.1 molar of your sodium carbonate, what you can use other than MV over 1000 is your M1V1 equals to M2V2. Alright? Where your M1V1 over here is before the mixing, M2V2 is after the mixing. So your M1 over here is the first concentration, 0.1 molar. The first volume is before the reaction, before you mix up the solution, so 50 milliliter. The concentration M2 is the one that we are looking for. The volume 2 is 70 milliliter. And from that, you can find the new concentration of your Na2CO3. That is the new concentration. And the new concentration calculated over here is 0.07143. But bear that in mind, this is the concentration of the sodium carbonate. We are looking for the concentration of carbonate only. Therefore, ratio 1 mole of your sodium carbonate, Na2CO3, will produce 1 mole of your carbonate ion. Therefore, the concentration of your CO3 2 minus will then equals to the same as your sodium carbonate because it's 1-to-1 ratio. So the concentration will again equals to 0.07143 molar. And that is the new concentration that we have in our solution. So you are done with both of the concentration. Then next, you are going to write the formula of your Q, where your Q over here will be equals to your barium 2 plus, multiply with the CO3 2 minus, substitute in the value that you have just calculated for barium 2 plus concentration, 0.02857, and another concentration is for your carbonate, which is 0.07143. And from that, you will be able to get your Q value. Your quotient calculated is 2.0408 times 10 to the power of negative 3. The KSP given in the question is 8.1 times 10 to the power of negative 9. Looking at the 10 to the power of negative 3 and the 10 to the power of negative 9, your Q and your KSP over here, which one is bigger and which one is smaller? Is your Q bigger or smaller than the KSP? Obviously, your Q is bigger than the KSP value. When the Q is bigger than the KSP value, that means the solution that you form is a super saturated solution. Alright, the solution that we form is a super saturated solution. And since it's a super saturated solution, what happened to precipitation? Will the barium carbonate precipitate? Yes. Alright? Yes, the barium carbonate will precipitate. Alright? So that is how we answer your quotient question to determine whether your solution is going to form precipitate or not. Whether your solution is a saturated solution, unsaturated solution, or even a supersaturated solution. So we have two methods to calculate the concentration that we want. Is either using MV over 1000 to find the number of mole and then change it to concentration, or you can use your M1V1 equals to M2V2 straight away. If you are very confident with this formula, then use it. Alright? Just bear that in mind, the concentration that you calculate is the concentration of the entire compound, your sodium carbonate. But what we want is only the ion, the carbonate ion. So make sure you simply do a ratio. Okay? To make sure the ratio is 1-to-1. Or if the ratio is not 1-to-1, then you need to find the new concentration. Alright? Simple. Let's try the second example given and also the last example for this video. So in the question stated that determine whether there will be precipitation occur if you have 50 milliliter of 0.001 molar of NaOH is added into 150 milliliter of your 0.00 molar magnesium chloride. And the KSP is given for your MgOH2, your magnesium hydroxide. The KSP given is 2 times 10 to the power of negative 9. So guys, who is the insoluble salt? Simple and straightforward. The insoluble salt over here is the one with the KSP given, which is your magnesium hydroxide. Okay? And the magnesium hydroxide will be formed due to the ion of your Mg2 plus and your OH minus. So, you already can see which ion am I looking for. Alright? So, before we start calculate, let's understand what the question is talking about. So, right now, I'm having a beaker. In the same beaker, the first thing that I pour in, 50 milliliter of 0.001 molar NaOH. Okay? The second thing that I pour into the same beaker is your 150 milliliter of 0.005 molar magnesium chloride. So what is the very first thing that you shall realize? The very first thing, the volume change. So you have a new volume total of 200 milliliter. Agree? And we know that the 200 milliliter over here is also represent 0.2 liter. Okay? Make sure you realize we need that in a liter. Okay? Knowing that your sodium hydroxide forming your Na plus and also OH minus. Your magnesium chloride forming your Mg2 plus and your Cl minus. Okay? So in your beaker right now, you will have the presence of your Na plus, OH minus, Mg2 plus and your Cl minus. Remember, they will change their partner. So when they change the partner, you realize that you are forming your NaCl, which is a soluble salt, and also your MgOH2. Okay? So which one are we looking at? Obviously, your magnesium hydroxide. How do I know I'm looking at the magnesium hydroxide? Because the KSP is given for magnesium hydroxide. Therefore, everything in this question is going to discuss about magnesium hydroxide. And what will be forming the magnesium hydroxide? Your Mg2 plus. Where is your Mg2 plus coming from? Your Mg2 plus that is coming from your magnesium chloride and also the OH minus that is coming from your NaOH. So do you realize how do we get the number of mole now? We need to find the number of mole of OH minus over here. We need to find the number of mole of your Mg2 plus over here. Alright? So this is what the question look like in a diagram. Okay? Alright, so now you have understand the question. Very similar like the one just now, right? So make sure you know who is your insoluble salt that we are going to talk about. That is always the first thing when you are having a solubility question. So the insoluble salt is your magnesium hydroxide, MgOH2. Where the ion over here is your Mg2 plus and your 2OH minus. Agree? Always remember there is a volume changes. So the new volume total is a 200 milliliter, which is equals to 0.2 liter. Okay? Simple. So proceed to the second step, which is writing the equation. So you have your magnesium hydroxide over here, solid, will then break into their respective ion, the cation and anion, which is your Mg2 plus aqueous, 1:1 ratio, and your 2OH minus aqueous. Alright? And the next is definitely to find the concentration that we want by using the number of mole method or by using the M1V1 method. Both will do. So make sure you have the correct data down. You have 50 ml of 0.001 molar of NaOH. Let's say for this one, we are using M1V1. So you will have your M1V1 equals to your M2V2. Your M1 over here, 0.001 molar. Volume is 50 milliliter. Your M2 is the one that we are looking for. The new volume is 200 milliliter. So the new concentration of your NaOH calculated over here is 2.5 times 10 to the power of negative 4. Okay? But that is the concentration of NaOH. We are looking for the concentration of OH minus. So 1 mole of NaOH, which is quite obvious, forming 1 mole of OH minus. Since it's a 1-to-1 ratio, therefore, concentration of OH minus is the same, which is 2.5 times 10 to the power of negative 4 molar. Okay? So, right now, you're having your OH minus concentration already. You're done with the OH minus. Next, we move on to your Mg2+. Your Mg2+ coming from 150 milliliter of 0.005 molar of your magnesium chloride. So, we already used the M1V1, M2V2 method. Just to make sure you understand, I'm going to show you both methods. In the exam, you can choose any one of the method that you prefer, either calculating the number of mole or either using M1V1, M2V2. Any one that is easier for you, okay? So for this one, we are going to use the number of mole method where you are going to use your MV over 1000. So your MV over 1000 over here equals to 0.005 times 150 milliliter over 1000. So you are calculating the number of mole of your MgCl2 over here, where the number of mole of MgCl2 is 7.5 times 10 to the power of negative 4. Bear that in mind, we are not looking for the MgCl, we are looking for the Mg. Therefore, 1 mole of your MgCl2 will actually produce 1 mole of your magnesium 2+. It's again a 1-to-1 ratio. Therefore, number of mole of your Mg2+ will then equals to 7.5 times 10 to the power of negative 4. Question asking for concentration. You need concentration to calculate the quotient. So, concentration of your Mg2+ will then equals to the number of mole, 7.5 times 10 to the power of negative 4 over the volume in liter, 0.2 liter. Mole per liter is the formula of concentration. And your Mg2+ calculated is 3.75 times 10 to the power of negative 3 molar. Okay? And that is the concentration of your Mg2+, using the MV over 1000 method. Both methods are acceptable. It's either M1V1, M2V2 or your MV over 1000 and then change it to concentration. Any one that come into your mind during the exam. Alright? Next, write the formula of your Q. Your Q equals to the concentration of your Mg2+. Multiply the concentration of OH minus to the power of 2 due to the coefficient of 2. So make sure you have the power of 2. Substitute in the concentration of Mg2+ that we calculated. 3.75 times 10 to the power of negative 3. Multiply with the OH minus 2.5 times 10 to the power of negative 4 to the power of 2. Okay? Press the calculator correctly. You realize that the Q calculated is 2.3438 times 10 to the power of negative 10. And the KSP given in the question is 2 times 10 to the power of negative 9. So the same thing, is not needed to look at the number in front. It's important to look at the one behind. We are having times 10 to the power of negative 10 times 10 to the power of negative 9. So is your Q bigger or smaller than KSP? Negative 10 and negative 9. Obviously, your Q is now smaller than your KSP. And if your Q is smaller than your KSP, what type of solution we are forming? We are forming our unsaturated solution. Alright? That is our unsaturated solution. And since it's an unsaturated solution, will you have precipitation occur? No, there will be no precipitate occur, right? Why there will be no precipitate occur? Because it's an unsaturated solution. Simple, easy. So this is how we are going to find the Q, or this is how we are going to determine whether you have precipitate or not in your solution. Alright? And that's it about this video. This is everything about quotient and KSP. How do you find the quotient Q, and how do you compare your quotient with the KSP, and what is the comparison represent? If you have any question, drop it in the comment below and I'll get back to you as soon as I can. I hope you liked the video and also subscribe to my channel, and I'll see you again in the next video. Thank you for watching.
TunePocket.com